In 0.3, we're going to take what you did in 0.2 and start adding some mathematical operations with it. In 0.2, you were simplifying only. Now what we're going to be able to do is we're going to be able to multiply radical expressions, and we're going to be able to add radical expressions. The main idea here will be multiplying, but the more advanced concept will be adding the rational expressions. I'm going to have to show you how to be able to do that. So here we go. The first thing I need to highlight is that there are some directions that when I first read them, it confused me. The direction said, assume all variables are positive. And because I read those and I had to look it up, like, why do they say that? What would happen if? And we didn't really mention this at all in 0.2, but I want to mention it here. If I were to simplify the square root of x squared, let's just do that. What I told you about that yesterday is that you're looking for two things, what could pop out, and most all of you would say that this is equal to x. Okay? If we assume that all variables are positive, this answer is correct. If you do not assume that all variables are positive, this answer is incorrect. If you don't assume this, the correct answer is actually this. And I know this is going to be a hard concept for you because this is really more advanced. This is probably stuff that's for next year's type of students or next year's type of class, maybe even the following. If you were to graph this, you would see the same graph as this. Okay? So here's the deal. The only reason I bring that up is I wanted you to know when it says assume all variables are positive, this is how we have been doing it in 0.2. We're going to continue to do it this way. If it didn't say this, this is how we would have to do it, and you wouldn't see anything like that unless, of course, it was like extra credit or a hard problem or something along those lines. Okay? All the problems are going to be like this, like that. Okay? So let's look at some examples. I picked out number 2, 3, 8, and 9. When multiplying radicals, they have to be the same index. What that means is square roots can only multiply other square roots. Cube roots can only multiply other cube roots, and so on. So that's why it says have to be the same index, or otherwise known as the same nth root. The easiest way for me to remember what to do here is I use insides, multiply insides, and outsides, multiply outsides. Why do I say that? Because there are these things inside the radical. They will multiply the things that are inside the radical. You have some things that are in front of the radical or outside of the radical. Those are going to multiply the things that are outside or in front of the radical that's there. Let's look at an example. Number 2. Number 2 says root 12 times root 30. You can simply, well, this is inside, that's inside. Instead of making it bigger and then breaking it apart, I'm going to recommend to you that you break it apart first. Root 12 is the same thing as root 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. That works. 2 times 2 times 3. Breaking it apart is easier when it's just 12. If you were to do 12 times 30, you can do that. But 12 times 30 is 360. Then you'd have to break that apart. So I'm going to recommend doing it this way. You do not have to. I just recommend it. And that's what 30 is. 3 times 10 is 2 times 5. And so if I think about all these insides, technically the insides multiply the insides. I have a 2, a 2, 2, a 2, another 2, another 2, a 3 and a 3, and a 5. And we're looking for a square root. We're looking for 2 factors that are the same. I see one pair of 2s. A 2 can pop out. I see another pair of 3s. A 3 can pop out. The 2 and this 5 don't have a pair, so they have to stay inside. What do you do with things when they stay inside? You put them back together. You multiply them out. So on the outside I have this 2 and the 3. What do I do with those? You multiply. Outsides times outsides is 6. Root 10 is my final answer. By the way, I want to show you, you could get the same exact answer if you were to multiply 12 times 30 and you got 360. You could do that and then breaking it apart. You can get the same answer. You might have done 6 times 60, 2 times 3, 6 times 10, 2 times 5. I just don't see why you would want to make it bigger and then make it smaller. I would just make it smaller, put all the smaller pieces together, and look for pairs. I think it saves a step. That's my advice. I think that's the shortest way to do it. But like I said, you can still do it this way if you want to. It just makes it bigger, and then there's an extra step. Number 3. I have 3 root 5 times 4 root 8. Insides times insides, outsides times outsides. I'd probably do the 3 and the 4 first. What is 3 times 4? Thank you. I have a 5 and I have an 8. I know that there's no 5s in the 8, by the way. But the 8 can break down, I'm pretty sure, to 2 times 4 and 2 times 2. I like to make them smaller before I multiply them. Do you see any pairs? Is there going to be a pair of 2s? So then the 2 gets to pop out. What happens with that 2? It's going to multiply that 12. And then what's left inside? I have a root 5 here and another root 2 that doesn't have a partner. What do we do with those 2 numbers? Let's put it all together. What's the number in front? Say it out loud. Root. What's in the number inside? And there's nothing else you can do with that. That's your final simplified answer. And 2 and 3 are your basics. And why are they your basics? Because they didn't have any variables in them. But as you move forward, the more advanced type of questions, the nice medium level problem is like number 8, number 9. There's a bunch of variables and the answers look kind of funky, but they're not that hard to do. Let's do them. I have a number in front. I have a 21. I would probably break the 21 down. 21 is 3 times 7. Let's go with that. What about 56? I heard 8 times 7. And I'm going to break the 8 down to 2 and 4 and 2 and 2. I consider these all insides. This is inside. That's inside. So I'm looking at all of these together. I save myself a step by not writing it all out unless I need to. If I need to, then I'll write out radical and then put all that stuff on the inside. Now I'm going to look for some pairs. Got a 2. I'm going to put the 2 next to the 12 so it multiplies it. Is there another pair? 7. And I'm going to go over here, circle that 7. I'm going to put that over here next to the 2 and the 12. As I look, I see a 3 and a 2 that are by themselves. Those are not going to be able to fit anywhere. So I'm going to put those back together, and they're going to be inside this radical. So I kind of just like leave it there so I don't get lost. I have 2 factors of A. I have 3 factors of A over here. That means I have 5 factors of A. But I'm looking for 2 to break out. Do you know how many are going to break out? Can you do that in your head? So A squared is going to break out. I'm going to put A squared. If A squared breaks out, what's going to be left inside? Now, for anybody who did not follow that, what we're doing is we're going A squared, A to the third. There are 5 of these A's. We're already in our head going, hey, we can take out one of these A's and another A and put that together. I wrote a shortcut for you on that in the 0.2 notes. In 0.2, I said, if you know that there's A to the 5th, and you're taking the square root, 2 goes into 5 2 times. A squared is going to pop out, and 1 left over will stay on the inside. I don't know if that'll help you, but that's how I see it. B to the 5th, 5 factors of B. B to the 3rd, 3 factors of B. Together I have B to the 8th on the inside. Do you know how many are going to pop out? And so now I kind of have everything that I need on the outside. The only thing I don't know is 7 times 2 times 12. I'm sorry. I'm going to take the lazy route, and I'm going to do 7 times 2 times 12 on my calculator, and I got 168. So you guys can't see that, but there you go. Right there. 7 times 2 times 12 is 168. So 168. I have an A squared that popped out, and I have a B to the 4th that popped out, and the 6A is left over. There are no more B's inside there. This answer is really messed up. So what I like to do whenever I do something like that, I always rewrite my answer so that I can be clear. 168 A squared B to the 4th root 6A. The only reason I say that is because if you're taking a quiz or a test and I can't read it, if I have to guess, usually you don't get all full credit. So keep that in mind. If I can't read if you were doing what I just did right there, rewrite it. It helps. It'll help your grade, especially if you know what you're doing. Number 9. Let's go ahead and break apart the 48. Six times 8, maybe. Oh, how about, or 16 times 3. Ooh, I like that better because it's bigger. Let's do that. 16 times 3 is 48. That way I can get a 4 and a 4 right there. Boom. Bigger. And I see a 3 and a 9, 3 and 3. I'm seeing the 2 multiplying the 5m. So I know that I'm just going to go like this and cross that off and put the 2 right there. And then I'm going to start pulling some pairs out. I got pair of 4s is going to pop out. Cross that off. 4 times 2 times 5. I see a pair of 3s over here. I'm going to pop that 3 out over there. And then I see another pair of 3s that pop out. So that means all the numbers go away, right? There's no numbers left inside this radical. And now, let's look at m's. Do you know how many m's are going to pop out? 1 pops out, but I'm going to have 2 in front, right? M times the m, which will be m squared. Let's cross that off. Done with m's. N's, how many n's are going to pop out? N to the what power will pop out? Okay, so let's put this all together. Let's write our final answer. 3 times 3 is 9 times 8, 72 times 5. Wow, goodness gracious. Pretty sure it's 360. Let me check that one more time. Is that what you all got? 360? And then we have m squared n to the third. Is there anything left inside the radical? Then that's how we leave our answer. So with that being said, do you know if this is rational or irrational? Let's go with that. Rational. If this one is rational, whereas number 8 would be irrational. The last thing that we have to do is how are we going to add radicals and or subtract radicals? When adding and subtracting, they have to have the same index. What does that mean? That means square roots can only be added to other square roots that are exactly the same. And it says same index and same radicands. That means radicands, that's a fancy word for what's inside the radical. Is root 7 the same as radical or root 63? No, those are different radicands. The same radicands would be root 7 and root 7, or root 63 and root 63. They have to have the same root, square root, and same radicands to be able to put them together. I cannot add these together right now. They're not like terms. Think of it in terms of like 2x or 7x and 7x. We can only add them if they're the same x, right? We can only add root 7s with other root 7s. So what we need to do first, before we put these together, is I'm going to break this root 63 down into like 7 times 9, 3 times 3. Does that root 63, does it simplify? How could I write root 63? Is that the same thing as something else? I think you guys hopefully will see it. This is 2 root 7 plus, what does that make? 3 root 7. Now we have the same index and the same radicand. We can add them together. What is 2 root 7 plus 3 root 7? It's the same thing as 2 boxes plus 3 boxes. It would be 5 boxes. The radicands do not change. You're adding them together. This is 5 root 7. Does it make sense? And number 17. 4th root of 64 plus the 4th root of 64. Is it the same index? Yes. Is it the same radicand? Yes. You have 11 times the 4th root of 64 plus how many of them are over here? There's this invisible 1 right in front. You have one of those right there. What is 11 times the 4th root of 64 plus 1 times the 4th root of 64? How many will that be? Times the 4th root of 64. The only thing that you have to do after this is you have to decide, is this in lowest terms? Can this break down further? Are there 4 factors of something? Because we're doing a 4th root with it. Let's figure that out. 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. 1, 2, 3, 4, 5, 6. That's 2 to the 6th power. I need how many to break out? 4. 1, 2, 3, 4 of these guys. That will break out and multiply the coefficient in front. That makes it 24. Times the fourth root of what's left behind. We put them together. And this is simplified. This is your final answer. Any questions? The last thing here that says classify the problems as rational or irrational. Let's go ahead and do this orally. This number 17, rational or irrational, say it out loud. Irrational. How about number 14? Irrational. Good. How about 8? Irrational. How about 9? Rational. And how about 3? Irrational. And how about 2? Irrational. Good. The only one that's rational is number 9. We're going to stop your notes right there.